Welcome back, everybody. Corey Anderson here. Today we're going to go over the neural activation, how your neuromuscular, or how your nervous system and the muscular system work together, which compose of the neuromuscular system. So, hope you have your notes out. Be willing to learn with me. Okay, so neural activation. Skeletal muscles will not contract unless they are stimulated to do so by motor neurons. Neural activation is the communication link between the nervous system and the muscular system. Motor neurons originating from the central nervous system communicate with muscle fibers through a specialized synapse called the neuromuscular junction. One motor neuron and the muscle fibers it connects, innervates with, is known as a motor unit. The point at which the motor neuron meets an individual muscle fiber is called the neuromuscular junction, or nerve to muscle. The junction is actually a small gap between the nerve and muscle fiber called a synapse. Okay, now remember, the synapse are the endpoints of your neurons. Now these synapses are what is connected to these motor neurons, because motor neurons are the point where the synapse and the muscle connect. Okay, and then the motor unit is basically just the function of the neuron shocking the muscle to contract. Okay, so electrical impulses, also known as action potentials, are transported from the central nervous system down the axon of the neuron. When the impulse reaches the end of the axon terminal, chemicals called neurotransmitters are released. Neurotransmitters are chemical messengers that cross the synapse between the neuron and muscle fiber, transporting the electrical impulse from the nerve to the muscle. Once neurotransmitters are released, they link with receptor sites on the muscle fiber specifically designed for their attachment. The neurotransmitter used by the neuromuscular system is acetylcholine, or ACH. Once attached, acetylcholine, also stimulates the muscle fibers to go through a series of steps that initiates muscle contraction. Okay, next we have the sliding filament theory. The sliding filament theory describes how thick and thin filaments within the sarcomere slide past one another, shortening the entire length of the sarcomere and thus shortening muscles and produce force. Now remember, the sarcomere is the functioning unit of the muscle, much like the neuron is the functioning unit of the nervous system. And what happens is, in this sliding filament theory, these acetylcholine, or the ACH, is being released into the sarcomeres. And then these in turn, now remember, the muscle filaments are the actin and myelin sites, where we went over on this page. The myosin then grabs the actin and then pulls it in, and that's what causes your muscle to contract. Okay, now the excitation contracting coupling, putting it together. Excitation contracted coupling is the process of neural stimulation creating a muscle contraction. It involves a series of steps that start with the initiation of a neural message or neural activation and end up with the muscle contraction, the sliding filament theory. Okay, so here's an illustration they have. Here's the bicep muscle, and here's the motor neuron. Now there are millions of these, all across your muscle sites, and these are what the neuron causes to. This is what the neuron shocks, and this in turn causes the muscle to contract, stimulating those sarcomeres. Okay. Now, I'm going to go ahead and read you the sliding filament theory table. Okay? Steps in the sliding filament theory are summarized as follows. 1. A sarcomere shortens as a result of the Z-lines moving closer together. Now remember, the Z-lines are just the points that separate the muscle contraction sites. They're the sites that each actin and myosin, myosin. What is it? Wait. I just forgot the name of it right now. Okay, actin. What is myosin? Actin and myosin, the the points of attachment where each one has its own individual line. Okay? So 2. The Z-line's coverage as the results of myosin heads attaching to the actin filament and asynchronically pulling through power strokes the actin filament across the myosin, resulting in shortening of the muscle fiber. Okay, so I'm going to go ahead and read you the motor units in the all or nothing law, then we'll go ahead and end it with this video. So the all or nothing law. Muscles are divided into motor units. A single motor unit consists of one motor neuron, or nerve, and the muscle fibers it innervates. As was discussed earlier, if the stimulus is strong enough to trigger one action potential, then it will spread through the whole length of the muscle fiber. More specifically, it will spread through all the muscle fibers supplied by that single nerve. Conversely, if the stimulus is not strong enough, then there will be no action potential and no muscle contraction. So in order for your muscle to contract, it's either going to shock it fully or it's not going to shock it at all. Motor units cannot, therefore, vary the amount of force they generate. They either contract maximally or not at all. Hence, the all or nothing law. As a result of the all or nothing law, the overall strength of the skeletal muscle contraction will depend on the size of the motor unit recruited, or in other words, how many muscle fibers are contained within the unit, and the number of motor units that are activated at a given time. It should also be understood that the size of motor units making up a particular muscle will relate directly to the function of that muscle. So, basically, what that sentence is saying, your thighs or your quadricep muscles have a lot more motor units than your biceps, for example, because they need a lot more contraction and electricity to cause the muscle to cause your leg to extend when you do a leg extension. Okay? So, for example, muscles that have to control price movements are made up of many smaller motor units. The muscles that control the eye movements have as few as 10 to 20 muscle fibers within each motor unit, allowing the fine control that eye movement demands. Conversely, large muscles and muscle groups, such as the gastrocnemius muscle, which are required to generate more powerful gross movements with far less fine control, have as many as 2,000 to 3,000 muscle fibers in each of their muscle units. Okay, so the all or nothing law, remember, it's either going to contract it fully or not at all. And each muscle fibers have, each motor unit has a specific amount of muscle fibers due to what that muscle function has. Like it's saying your eyes only have about 10 to 20 muscle fibers, you should say, within each motor unit, because it doesn't require as much strength to move your eyes around as to your gastrocnemius has as much as 2,000 to 3,000 muscle fibers within motor unit, because it's required to move your body and walk and get around. So that being said, next we're going to go over muscle fiber types and then the summary. Muscles as movers, and then the summary. Then we're basically done with the muscular system. If you like this video, please share it, and please subscribe, and thank you guys for coming and learning with me. I'll see you on the other side of the galaxy. Take care.